Okay, this is one of my favorite problems in the entire one. Okay, find h such the car will make it around a loop without falling. Find x that occurs when the car impacts the spring. This is one of those physics problems that's just fun to do. You break it up into a couple different pieces and just wow everybody with your physics knowledge. So you have a height here, you've got a plane here, you've got a little cart here with a mass m coming down. You've got a plane, you've got a loop-de-loop that it goes around. You got an R, comes here, hits a spring. Okay, there's a wall. There's going to be a distance x there. Okay, so basically this is set up a couple different ways. Okay, so for the first one here, for the mass coming down, you need to convert potential energy to kinetic energy. With all these problems, potential energy, kinetic energy are gonna help you solve everything. Okay, so here, as the mass is coming down, kinetic energy is equal to potential energy. Okay, so that's 1/2 mv1 squared, velocity of this. We wanted it at velocity because that's going to help us here and here. Okay, and that's the square root of 2gh. Okay, that's your potential energy. Sorry, that's what you're going to solve for. It's mgh, potential energy. And then just solve for v1, and you're going to get the square root of mgh, 2gh. Because masses are going to cancel. 2gh. Okay? So that's your v1. All right, next, you've got a velocity here, and now you're going to go around the loop. Well, when you go around the loop, what have you got going on here? You've got circular, forces and stuff, so you've got centrifugal force that's going to come into play. So the minimum velocity is going to be at the highest point when it's going around it, because it's going to go vroom, and then come back around, then loop back around. So here, in this case, there's going to be the minimum velocity at the top of it, which is just here. You got your mass m. So this again is kinetic energy is going to turn to potential energy right here. So so your centrifugal force mv2 squared over r is equal to mg. Okay. So your v2 you just solve for in this case. So v2, which is your minimum velocity there, is equal to square root of gr. Okay. So you got those two here. So now what you need to know is that the change in kinetic energy is going to be equal to the change in potential energy for the system, okay, as it's going around the loop. All right, so we're basically calculating for the final velocity here, okay, and then I'm going to solve for h. Okay, so here, the kinetic energy of the system, you have 1/2 mv1 squared minus 1/2 mv2 squared is equal to mg times 2r. Okay, so that's your kinetic energy here, 1/2 mv squared here, minus 1/2 mv2 squared, which we're going to solve for, okay, is equal to mg, your total potential energy up here, times r, okay, or times 2r, because it's radius times 2 is the diameter. That's the height of the circle. Okay, so we know that v1 is equal to the square root of 2gh, and we know that 1/2 m times the square root of 2gh, plugging that in, squared, mg2r. Okay, so in this situation, just moving the items around, I mean, obviously your m's are going to cancel and everything, so you have 1/2 m v squared is equal to g times h minus 2r. And v2 is equal to square root 2g times h minus 2r. Okay? So you basically just solve for h in this case. So h, so v2 min is going to be equal to that v2 velocity, which implies, alright, I think I can fit this in here, square root of 2g times h minus 2r is equal to square root of gr. So 2g times h minus 2r is equal to rg, and h is equal to 5 over 2r. Okay, so we found the height. Okay, by using the those conservation laws. That's basically everything we need to know. I mean, and then the velocity here, once it comes around, that velocity there is going to be equal to the same velocity there, assuming there's no loss. So you just use your, I think I should have enough room right here. Just use your basic 1/2 kx squared. You need to know that for a spring is equal to 1/2 mv1 squared. Okay, and just solve for x, and x is equal to the square root of mv1 squared over k. Okay, so main points here is that you've got potential energy when the mass is at the top here is going to be converted to kinetic energy. So you're going to have a velocity here. That velocity here is going to be the same as the velocity here, but the velocity here is going to be different because there's a new potential energy, the new minimum velocity. That new minimum velocity is basically going to help you solve for your velocity as it's coming around, and that'll get you your h. So one of those fun physics problems where you're going to break it up into a couple different pieces, and hopefully we'll take a look at it. Hopefully we'll take a look at it, go through it, work through it a couple times, and break it into its individual pieces. Excuse me. Okay, and then just so you know here, you have 1/2 mv1 squared minus 1/2 mv2 squared. That's your change in kinetic energy. That's why it's subtracted there. Okay, just wanted to touch on that. All right, next. What angle will give